Now we are going to discuss about geometric distribution, and for solving the practical questions on geometric distribution I have chosen paper 9709/51 for the session May June 25 to be the first question for solution, and we have chosen question number 2 for solving geometric distribution based questions. Okay, so let's see. Question number 2 a doesn't question number a of these question doesn't belong to geometric distribution, that's why we are skipping that one. Let's move on to question number 2b. Before we start writing the solution, we should know which distributions are called geometric distribution. Look, geometric distribution is primarily a distribution when the desired outcome is obtained, then experiment is over. That means experiment keeps on going on and on and on until we obtain the desired outcome. So it is actually there is no certain number of experiment is uncertain, but probability, individual probability for every trial or every experiment is fixed. And usually the question contains the words either until or first. Whenever you find one of the words until or first time, then we will directly understand that this is a geometric distribution. So simply geometric distribution, definition of geometric distribution is an experiment will be kept onward until we obtain our desired outcome. Let's see the first question, question number B from 2 of this paper. Let's read question number B. A fair eight-sided dice has faces labeled KANGAROO. The dice is rolled repeatedly. Find the probability that fewer than 6 rolls of this dice are required to obtain an A. So the dice was kept rolling on until we obtain an A. That means this is a geometric distribution, and it is the dice was rolled less than 6 times. So let us start our solution. We can start our question belongs to geometric distribution, and for geometric distribution parameter is nothing but the probability. Look at this. We our desired outcome is A. So how many A's are there? There are 2 A's out of 8. That means 2 over 8 is our probability, which is 1 over 4. So 1 over 4 is the probability of obtaining an A. That means our P is 1 over 4, whereas our Q, that means probability of not obtaining an A, is 3 over 4. Q is equal to 3 over 4. Well, then let us solve. They have told that it will be probability of, now we are going to find the probability x is less than fewer than 6 rolls. Okay, so x is less than 6 rolls means, what does it mean? It might be obtained among first 5 rolls. Less than 6 rolls means it was rolled for 5 times, and among these 5 times somewhere there was success. And the formula for this equal or less than a number is 1 minus, so out of 5 times, every time there was all times, all 4 6 attempts were not failed, all 5 attempts were not failed, somewhere there was success. So we will just subtract the probability of not obtaining A is 3 over 4. 3 over 4 raised to how many times? 5 times. It was rolled 5 times, and among this 5 times there was one success. And the formula of this is, let me show you the formula. Formula is going to be probability of x less than, suppose this is r. Okay, is equal to 1 minus 1 minus q raised to r. Q is the probability of not obtaining the desired outcome every time. So finally our result is going to be 1 minus 0.755 times. It is equal to 0.673. 0.673, and that's our answer. Let's read the immediate next question. The immediate next question says that find the probability that the second A is obtained on the sixth roll. So this is a little bit different actually. There are total sixth roll. Okay, so 1, 2, 3, 4, 5, 6. Among these six rolls, there were one thing is sure, that on the sixth roll there was nothing but success. Look at this, this is second A. So A was obtained for the second time on the sixth roll. But what about the first, fifth? Because we should not deviate from the question. Whenever outcome, a desired outcome is obtained, then rolling is over. So this is for the second A, and it was obtained on sixth roll. That means on the sixth roll there was nothing but success. So on the sixth roll we have obtained an A, but among the first five rollings there is no certainty of success. We succeeded once among these five, but we don't know what is the exact row number of roll when we got succeeded. So this is somewhat a binomial distribution, and the final one is nothing but success. So let us write here probability of second A on sixth roll, on sixth roll or turn, sixth roll is equal to, so on the sixth trial we got success, and the probability of success is 1 over 4, 1 over 4. But among previous five trials we don't know the number of exact success, but there is only one success among the first five. So among five there is one success, 5 choose one success. The probability of being succeeded is 1/4, and probability of failing, that means rest four times we failed, so it is 3 over 4. So once we succeeded and four times we failed, it is 4. Let's simplify this more. If we simplify it more, it is going to be uh, 5 choose 1 is actually 5. 5 will multiply 1 over 4. How many 1 over 4s are there? 1 over 4 is 2 times. So 1 over 4, 1 over 4, 2 times, 2 successes and 3 failures. Not 3, 4 failures. So 3 over 4, total there were 6 attempts, and out of this sixth attempt, 2 times we succeeded and 4 times we failed. So finally our probability is going to be 5 into 1 over 4 squared into 3 over 3 raised to 4. It's equal to 0.0989 is our probability, desired probability, and that is the final answer. I think you got the clarification of geometric distribution. Let's solve the next question from paper 52, question number 4 BC. The next question has been selected from paper 9709/52 for the session May June 25, and we are going to solve question number 4, which says vehicles approaching a certain road junction from Bromley must go either left, right, or straight on. Over time, it is known that 30% turn left, 25% turn right, and 45% go straight on. The driver of each vehicle chooses a direction independently of all other drivers. So this is actually whether this is geometric or binomial not specified. If we go through question number B, then we can see that this belongs to geometric distribution. Let us see what B says. B says, find the probability that from the vehicles approaching this junction from Bromley today, the first vehicle, look at this, the word, I think you remember, initially I have written, if the word first or until is mentioned in the question, that belongs to geometric distribution and it contains the first vehicle. Okay, so for this word, it belongs to geometric distribution. Which goes left is before the ninth vehicle, somewhat similar to the previous question. So let us start our solution. X belongs to geometric distribution, and for geometric distributions our parameters is the probability, only probability. Let's see in the left what is the probability of turning to left. 30%, look, 30% turn left, so it is 0.30 is our probability. 0.30 is our p. Okay, so our p is equal to 0.30, hence our q is going to be, how much is q? Rest of the probability is 0.70 is not turning to left. Well, then let's solve the question. The question tells probability of, they have told us to find before ninth vehicle. Look at this, before ninth vehicle. So x is less than or equal to 8. That means before 9 means 9 must not be included before 9. But among before 9, I mean among first 8 trials or experiments, we don't know when the first vehicle turned to left. That's why we will solve it. The formula is, as I have written in the previous solution, formula is 1 minus q raised to r. Q is our zero point 0.7, so 0.70, how many times? 8 times. I think you have got my points, that among the first 8 turns, we don't know when a car or a vehicle turned to left. That's why in all 8 turns there is no failure, there is one success, but we don't know. That's why the formula is 1 minus q raised to r. And if we simplify this, it is going to be 0.942. 0.942 is the final answer. Then let's see the immediate next question, which says, find the probability that from the vehicles approaching this junction from Bromley today, the second vehicle to go to left is the seventh vehicle. So this is also somewhat similar to the previous question. Let us write here probability of, look at this, second vehicle second vehicle second vehicle second vehicle to left, to the left, on which trial? On the seventh trial. Second vehicle to the left on seventh trial or seventh experiment. That means seventh vehicle turned to the left for the second time. This is the second vehicle actually. So what is our formula? That means on the second, if I draw a scenario, look, there are 7 trial. 1, 2, 3, 4, 5, 6, 7. On the 7th turn, there was nothing but left. 7th vehicle turned left. This is sure. Okay. So we can apply this one. That 7th turn, our probability is 0.30. So on the 7th trial, there was nothing but success. Now, among the previous 6 turns, these 6 turns, we don't know when vehicle turned left. That's why we will have to use here 7 choose, sorry, 6 choose among 6. 6 choose among 6, there is only one vehicle who turned left. So there is only one left, and the probability of turning to other direction is zero point 0.7, that means q zero point 0.7. But how many vehicles among 6? 5 vehicles turn to the other directions. So if we simplify it more, it is going to be 6 choose 1 is 6, and how many point 0.3 are there? 0.3 two times, because there were 2 vehicles turning left 2 times, and 0.70, the rest of the 5 vehicles out of 7, rest of the 5 turn to the other direction. And if we use our calculator, our probability is going to be 6. Then if we round it up to the 3 significant figures, it is going to be 0.0908. 0.0908 is our final answer. Let's see the next question. The next question belongs to paper 9709/53 for the session May June 25, and we are going to solve question number 3, all of them from 3. Let's see what the question says. A fair six-sided dice with faces labeled 1 until 6 is thrown repeatedly until A3 is obtained. Look at this. Until is the clue word of this question. That's why we can decide that this belongs to geometric distribution. The number of throws taken is denoted by the random variable x. And they have told to find when there were 8 throws to obtain A3. So our, we can start writing x belongs to geometric distribution whose parameter is 1, or as this is fair, so for obtaining a 3 there is 1/6 our probability. Okay, so if p is 1/6, then q is going to be surely 5/6. 5/6. Okay, then they have told us to find that 8 rolling or 8 spinned where it was thrown, 8 throws were required to obtain A3. So we can write probability of x, that means 8 throws. So among 8 throws, it means on the 8th throw it was success, so which is 1/6. And among the previous 7 throws, all of them were failed. So the probability of failing in each of the throw is 5/6, but we failed 7 times back to back for obtaining A3. I think you have understood my point. That means we got succeeded once, and previous 7 times it was absolute failure. So the answer is going to be 1/6 into 5/7 raised to 7 times, equal to 0.0465. 0.0465 if we round it up to 3 significant figures. Well, then let's move on to the next question. It says find the probability when it was thrown x less than 9. So it is equal to probability x less than 9. What does it mean? It means actually we obtained A3 on 8th throw or before that. That means less than 9, one thing is sure, on the 9th throw, 9 throws were not required, but 8 throws were required. Among these 8 throws, there was 1 success and 7 failure. But as we don't know when we got succeeded, so we will have to write the formula we know is probability of, I am just writing this for reminding you of the formula. X is less than suppose r times, okay, equal to 1 minus q raised to r. Okay, so simply we are going to apply the same concept. 1 minus 1 minus 1 minus, so the q, our q is 5 over 6. 5 over 6 how many times? 8 times. 8 times. That means among these 8 times, somewhere we got succeeded, but the number of throw is not known to us. That's why we apply this formula. Then finally our result is going to 0.6. So our final answer is going to be 1 minus 5 over 6 raised to 8 is 0.767. 0.767, which is our final answer. Okay, let's see what the immediate next question says. The next question, immediate next one says, find the probability that A3 is obtained for the second time before the sixth throw. Yes, this is a twisted question, and remember, this is absolutely different from all of the previous solutions. If we analyze the scenario 1, 2, 3, 4, 5, 6, 7, 8, among these 8 throws, actually no one has been certain. It's absolutely uncertain. Look at this, neither for the first one nor the second one. In the previous solutions, one of the solutions we have done that at least the second one was fixed. Second success was fixed at the seventh or eighth trial, or fifth or fourth trial. That means it was the total number of trial was given, and the finally it was written that the final trial was nothing but success. But here look at this, even the neither the second one nor the first one, for the second time before the sixth throw, that means second one is not also certain. There are many possibilities of this. That's why it should be done in a different way. So once again, I am requesting you, don't get confused. In the previous ones, actually it was told that second success was obtained on a particular throw. It might be seventh throw there was second success, or eighth throw there was second success. But here there is no particular number of throws, neither for the first success nor for the second success. So we'll have to analyze the scenarios gradually. So let us start our writing. Probability is equal to probability of, if we write it, it is going to be mm, second A, second A, second A on or before sixth throw is equal to, it might be, we'll have to calculate the probabilities individually. So what are the possible cases? He might be succeeded in the first two cases. So first throw there was success, and in the second throw also there was success. Okay. Or there were three throws. Among the three throws, third throw was definitely success. Third throw is success. But between the first two throws, there was one success, one fail. One success as well as one fail. It is 5 over 6. Okay, I think you are getting my point, that if we assume that uh, three throws were required, among these three throws third throws was success, that's why 1 over 6. But between the previous two throws there was one success and one failure, that's why we have written 2 choose 1 multiplied by one success and one failure. Okay, let's consider if there were four throws. So among four throws, fourth throw was success. Fourth throw was success, not 1 over 4, 1 over 6. 1 over 6, that means fourth one is success. But among the first three trials, three experiments, there was only one success and two failures. So one success and probability of failing is 5 over 6. 5 over 6, how many times? 2 failures. So this is the probability when we assume that he succeeded for obtaining second A on the fourth trial or fourth experiment. Then he might get succeeded on fifth trial. On fifth experiment, it was nothing but success. But among the previous four trials or four throws, there was one success, three failures. One success and three failures into three. Out of three, there was one success and sorry, out of four there was one success and three failures. So probability of failing is 5 over 6 and he failed three times. So these are the all possible cases. Look at this, we cannot include sixth time because they have written that before sixth, look at this, before sixth throw the second A was obtained. So before sixth means actually until five throws. It required five throws to obtain A for the second time. But it is not particular or certain that on the sixth, on the fifth throw there was success or not. I think you got my point. If I recap this, actually the concept is they have told before sixth throw there was second A obtained, but they didn't mention whether on the sixth throw they obtained second A. Sixth throw is not fixed. I mean fifth throw. Before sixth throw means fifth throw. So here we will have to rectify. It cannot be on or before. It is actually before. Okay, it is not on or before because they have told before sixth throw, so on cannot be included here. It's a wrong concept. Before sixth throw, so before sixth throw means there were five throws. Among these five throws he might be succeeded in the first two cases, or he might be succeeded for three trials, and he might be succeeded on four trials, or on fifth trial he got succeeded. So among all of these cases, one is particular success and rest of them were failed, for which we have applied the binomial theorem. So let us simplify this. 1 over 6 squared plus, here 2 choose 1 is 2. So 2 into 1 over 6. 1 over 6 two times. Actually every cases there were two A's. So success were two times. And 5 over 6. 5 over 6 was once. And again 3 choose 1 is 2. And success definitely two times because two times we obtained A and rest two times we failed. So 5 over 6 two times. And here also 4 choose 1 is, let me zoom it out, 4 choose 1. Okay, 4 choose 1 means 4. So if we can write 4 into 2 successes, so 1 over 6 two times. And how many times failure? Failure occurred three times. 5 over 6, three times failure, two times success. I think you got my point. So you cannot compare this solution to any of the previous solutions because this is absolutely an exceptional question, twisted question. So please don't get confused. Simply you can think that he might get succeeded in the first two trial, or among three trials third one was success, first two were failure. Third one success, and between first two one was success, one was failure, but we don't know which one was success or failure. That's why we have applied the concept of combination, two choose one. Then in the third case there were total four throws. Out of four throws, here I am talking about this one, here there were four throws. Out of four throws, fourth throw was nothing but success. So for fourth throw it was 1 over 6. But among previous three throws there was one success, two failure. But we are not certain about the number of trial when we got succeeded. That's why among three there is one success, two failure. Thus we kept on doing till the fifth trial. Then finally our result is going to be, if we use our calculator, it will show that our probability is 0.1962, that means 0.196 if we round it up to three significant figures. And that's all about the topic of geometric distribution for the session May June 25. And I believe that the third one is a little twisted, but I tried my level best to clarify this. So let's move on to the next topic of probability and distribution. There lies a mistake over here. Actually, 3 choose 1. 3 choose 1 is 3. It should be 3, not 2. So 3 times 1 over 6 squared into 5 over 6 squared. Thank you all for being with me. Let's move on to the next topic.